Hello and welcome. What if I told you that you could make a breakout game in under 60 lines of Python code? I'm talking about this game. So this is only possible thanks to a new Python library called Ursina. Now, Ursina is an environment that's designed to help Pythonistas make games. So it's a bit like Pygame with 3D functionality and even sort of more radical shortcuts in terms of what you can do. So it would be something of a cross between Unity and Pygame with a lot of automatic functions. So yeah, that is the game we're going to build, and we're going to do it step by step, taking baby steps through essentially a set of tutorials I've pre-prepared. So on my website, you're going to be given a link to this. So there's going to be the cheat sheets page, and this is the Ursina cheat sheet. Now the Ursina cheat sheet is going to have, I think, 6 steps in program. So we're going to start by just drawing shapes. Then we're going to go on to, I don't know why this scrolls slowly, but then we're going to go on to rotate those shapes. After rotations, we're going to do some collision detection. Then we're going to create more objects. We're going to have like a room where the ball bounces, and you could see sort of how that works out to be the breakout game. So not only will you be able to just watch this and learn how to do it, but you'll be able to download this PDF cheat sheet that's going to make your life easier. Okay, so should we get started? Let's do it. So how do you import Ursina and just basically run some code that does something? So it's going to be the general import from Ursina import star. That basically gets in all of the functions within the library to work. Now you need to basically create the app object, app equals to Ursina, and then you got to run the app. Now this won't do anything other than create a sort of blank screen like that. Check that out. So that's your Ursina, and you can put stuff on that screen without actually having to do any sort of special function. So you can create like a game object. So this would be like a sprite in Pygame. And that is called an entity. So if we were to create a shape like square, and square would be an entity. And that entity has a collection of attributes. So we're going to say the model of the entity, model of the entity is a quad. And then we're going to specify where it is and what color it is. So perhaps we're just going to say color equals to color.blue. And scale is, now the scale of it, basically, this is sort of the weird thing. The Ursina dimensions go from -4 to 4 on the y-axis, and then -6 to 6 on the x-axis. So it's sort of like a 4 by 3 dimension. So it's not really using pixels as one would expect. But don't worry, go with it. So if that is the scale, I think this already might be enough to display it. Model is not defined. Well, that's because I didn't use the equal sign. Well, let's try that again. So yeah, now we've gotten a square on the screen. So you can basically specify like X, Y positions, but you can just say something like position equals to, and this is going to be like X, Y, Z. So let's just say we wanted to move the square up. You could say 0, 1, 0. So I would expect that square to move up a bit. Position, that needs to be separated with a comma. So yeah, squares moved up. So this is how you draw shapes. Now you can change this around to make this a circle, for example. So maybe we can just copy this and say you know, circle is a different entity, circle is a different entity, and then the shape is a circle. And maybe we're going to draw it somewhere lower. And all of a sudden, you're going to see a square and a circle, and then you can change color dot orange. So you get the idea. Very, very easy to draw shapes on the screen. Now, you can do something called editor camera. And this will allow you to sort of drag the environment and just see, hey, so that this is painted, there's nothing behind it, but you can right click and just observe, you know, your entities in a three-dimensional space. Okay, so that sort of covers the very basics. Let me show you something else. Now, this is kind of crazy. There is a function called update. Now, when you define the function update, this automatically runs once a frame. And I mean, the Ursina engine is ticking over at 60 frames a second. So this is going to do stuff once a frame. And you can do, for example, like square dot rotation and underscore x. And you just, I don't know, add some stuff to it. Plus equals the 2 maybe. So you'd expect the square to start spinning, and there it is. Like I said, there's nothing on the back of it. I mean, you could have done, now you could do the same thing for like y as well, and now it's gonna like spin on 2 different axes. There you go. And you can do the same to the circle if you want. So yeah, this thing actually updates the movements of all your entities. So basically the structure of an Ursina program is going to consist of like defining whatever we're going to have in terms of objects. I mean, entities are objects. And then defining the sort of rules of motion that they follow. I imagine in between, like depending on what you want to do, you might want to define some of your own customized functions. But, you know, with this structure as it is, we can create sort of bare bones of the movement dynamics of a game. So now that we've done that, let's see if we can just create a collision, because collisions are going to make our life more interesting. So perhaps, like we got that circle already, now we can bounce the circle off the square or something like that, right? So maybe position the circle to go up, like 2 there, and maybe make the square go down, like, I don't know, -3. Maybe make the square be wide, like 8. Let's just see if this is gonna position them correctly. Yeah, I don't know. Let's not spin the square. I'm just gonna make that as an empty function, because why not? And let's see if that's like, yeah, maybe move that square -2 here, because I want to be able to see it, right? And I'll tell you what I'm going to try to do. I mean, that's, the ball's like way too big. 0.5. Come on. I want to make the ball bounce off of the square, and then that way we can actually have ourselves a collision. So how is that going to work? Okay, so first things first, let's make the circle, the ball, full. So circle dot y minus equals 1. So we increment it down by, I think, yeah, I don't know, 0.1 maybe. Let's try this, see what happens. Yeah, it falls. 0.01. What about now? Yeah, that's nicer. So what I want to do is I want to make that bounce off of the edge and see what we can do with that. How do we create that intersection? All right. So this is going to require the dot intersects function. So I'm basically going to copy one of the examples that Ursina has provided on their own website, which was like the Pong game. And I'm going to say hit info equals to circle.intersects. Now, that hit info here is going to be an object that's going to have like some attributes like hit info dot entity, for example, and that's going to be able to identify an entity. But it also is going to have this. So you could basically check if hit info dot hit. So any given frame, like the dot hit attribute, is going to give you a boolean, a true, if there has been a collision. So this is like the simplest possible example. It just checks if the circle collided with something. Well, if the circle collided with something, you want it to bounce right back. And I guess that this would mean that this here has to change. So maybe I'm just going to create like, watch this, circle.dy. So that's going to be like the sort of delta on y. And in the circle, I'm just going to add dy equals to 0.01. And if there's an intersection, then I can just say, ooh la la, circle.dy equals to negative circle.dy. And watch, this should be a bounce. Huh? Well, that's... I guess, what am I missing? I think we needed to specify what type of collider we're using. So I'm just going to say collider equals to the box. So, I had assumed that the collider was like a default parameter, but no, I think you need to specify. So, by using the box collider, I mean, you can actually change the view here. You could see it bounce, but that's we're basically treating the ball like it is a box. You can use a sphere collider, but a sphere collider really, like, this is an infinitely thin 2D shape. A sphere would make that a 3D shape, and that would be a bit awkward. So like boxes is sort of the easiest one to use. I know this from trial and error. All right, so we can draw some entities, move them, collide them. Now we can actually begin to attempt to make our game. So what's that going to take? Well, let's sort of break up the pieces and then try to start coding them one by one. So I guess the first thing you want to do is build some walls, right? So like the ball's going to bounce off of the walls, and you can just start by renaming that the ceiling, and then we can figure that one out. I guess we're gonna need to create a ball, and we kind of already have the ball, so that's nice. Well, after that, you create a paddle, so something to bounce the ball. So that's gonna be 3. Create a paddle. After you've created a paddle, you gotta build some bricks, right? Like create some bricks to destroy. And after you've got some bricks, I mean, you've got to then have an update function that handles ball movement and collisions. So I suppose the number 5 is really the hard one. And these guys, well, this is just essentially, creating this entity function and calling it however many times. I suppose we're going to need some precision. So I'm going to perhaps copy some, trial and tested code to make this quicker and easier for you guys. And once we've created all of the objects, then it's going to be a question of writing the logic to make the whole thing work. So let's get started. Let's run this and just have a look at our circle's not defined. Yeah, because that was the ball. I guess we don't really need the logic here. I'm just gonna pass. And all I want to do is just figure out how to do the walls, right? Also what color to do them. So ceiling, I'm going to go with orange. I'll stay true to the thing we did before. So scale, that's if 8 is good enough. Let's make that like thinner. 8, 0.2. Now the position, hey. So if ceiling, it's gonna be like ooh, very nice, very nice. That's gotta be like not -2. That's gotta be 2. Okay, that could be our ceiling. And now we're gonna do left wall, right wall. So let's try that, left wall. So the scale goes opposite here, 0.2, 8. I guess 6 would be, because 8 is the width of the screen, 6 would be the height. Position, let me make that 0, -3. Is it -4 in the width? I'm not sure. We'll find out. Yeah, I think that's got to go like -4 or something like that. -4 going to be off the screen. We're about to find out. Yeah. 3.5. So the scales are just, yeah, they're just a tad weird, right? I don't even know. Like 3.6 seems to be the right number. You can actually modify the scale. There is a special function you can call. You can check that out on the official cheat sheet. But I warn you, the official cheat sheet it's a bit complicated. I spent days studying it before I could build anything. So I mean, if that's going to be the right wall, then that should just be 3.6 as opposed to -3.6. So yeah, we're on it, right? Ball. Why doesn't the ball start in the center of the screen? That'll make my life happier. Tunk. Ball's too big though. Maybe 0.2. And I think like I'm not sure like if you could just, because this ball's only got a radius. I'm not sure they draw it in a box. But anyway, that gives us the bowl of the right size. So paddle, paddle. Are we gonna go orange again? Well, we can basically copy the ceiling, right, and then change the dimensions and the rotation. Paddle, and that's an entity. What's gonna be the width of the paddle? Like let's try like 2. 0.2 sounds about right for the thickness. What about -2? Won't be enough. It'll be like -1.5 or something. What? Okay, like that's very bottom. And I don't know. I think that the paddle is like too wide. Scale. What if it was 1.1? Is this paddle too big? Yeah, 1.5. Okay, so we've got a paddle, we got these walls, we got a bowl. Maybe just make the bowl a different color. Bowl color white. There you go. So we got ourselves most of the pieces. Bricks. I'll tell you what, I'm gonna do the bricks after the logic. Let's see if we can like get the bowl movement. If we can get the bowl movement happening, and then we can figure out the rest. Now, one thing that I'd like to do with the bowl movement, if you remember from the advanced breakout, if I just stand here, the ball's going to bounce straight back up, right? But if I go here, the ball goes sideways. So you can actually, like, you could aim. Look at that. You can actually aim where to take the ball, thanks to like where it lands, right? So you're not really changing the direction. The direction is fully determined by which part of the paddle it lands, making it easier to aim. So that's what I'm going for. But to do that, I can't really just do the change in dx or change in dy. I'm going to have to use the built-in direction. So that was the direction was like, sorry, the rotation was the thing I was spinning at the start. So we're going to need to give the ball some kind of Z rotation, because Z axis is the one coming out of the screen. So where's the ball? Rotation Z. No, sorry, that's what we're gonna do here. No more this. We will have rotation Z equals to, I think 90 faces it downwards, but we're about to find out. Yeah, so we're gonna do that. So rotation Z is 90. That would make the ball face downwards. It doesn't have any movement, but that's okay. We can actually program that in. So now we're gonna figure out how to do the collisions. But one thing I realized we haven't done yet is figured out how to move the paddle. That's gonna be remarkably easy. So watch this. Paddle X, which is sort of a built-in. Paddle X equals to, and we can say held keys right arrow. So let's try that, and you can multiply that by so that's basically how long you're holding down the keys. So you're adding that. If you're holding them, sorry, you will multiply by how long if you're holding it. And that could be like time.dt. This, so if you're holding it, this basically turns into like a 1, and then you're adding for how long at time. Now, this might mean that it moves really slowly. Oh, actually, this is fine. Maybe I want to make it a bit quicker, like, I don't know, times 5 might be too fast. No, that's cool. I like fast. And I guess you can now say that that's the right arrow, and then you can say minus left arrow times time dt. I don't know if this is going to work. I think so. I think this is what I did the last time. So that would mean that if you hold both keys, it stays still. Ha! And don't... That's cool. Alright? How easy was that? So that, like, the event handling loop in Pygame would have been, to do this, would have been like 10 lines. Okay, so now we can move right and left. Now let's see if we can make the ball fall. So if we think about position equals to speed times time, ball dot position equals to ball dot right. So I mean that is like the turn times time dot dt times ball dot speed. Actually, let me just, so since you're in a two-dimensional space, position equals to direction times speed times time. So that would make sense, if especially if it works. Get rid of that. Okay. Oh, plus equals. So ball, it does have position. So the ball actually could be given a speed. Speed equals to, I don't know what 1 is, if that's slow or fast. Okay, there you go, it's falling. So this time it has a direction. So I mean, if I was to make this 60, you're gonna see it go sideways, right? So, okay. And by the way, speed 1 is nothing, so if it was speed 10, that might be more appropriate. Yeah, it's gone. So maybe 3. Cool. So now, now is going to come this idea of, well, how do we make the thing bounce? Now, we're using direction. Rotation Z goes from 0 to 360. So when it hits the paddle, we're going to need to translate that 0 to 360 to some number that depends on which part of the paddle is being hit. So we've got the basic movement there. So we're just going to do what we did before, right? So we're going to say hit info equals to ball dot intersects, and then if hit info dot hit. Now that means if there is a collision. If there is a collision, then you could say something like if hit info dot entity double equals to paddle, and we should have 3 if statements here. We should have the paddle, we should have the left wall, right wall, and ceiling, right? 3 more. Ceiling, left wall, now we don't have bricks yet, so eventually we're gonna have bricks, but let's just let's see if we can program these in, and then the bricks are gonna be the last thing I add. So these are the things that we currently have in our environment that the ball can collide with, and we're gonna need some rules for all of these. Now some of them are easy, like left wall and right wall. All that happens is sort of you say 180 minus. So like, watch this. Ball dot rotation underscore Z. So if you change the direction by 180, right? If you change the direction by 180, you just sort of go back the way you came from. So ball rotation equals to 180 minus ball z. Now, it should be the same for right wall or left wall, but let me just do it this way first. And let's point that ball in the direction of the right or left wall. So like what if this was 5? So now it's gonna hit that, and if it bounces right off of it, hey, that's good. And now it's gonna bounce off of the other wall. As you can see, I can still spin this, but the actual accuracy of these collisions isn't perfect. Weirdly enough, Ursina does a better job in 3 dimensions and 2 dimensions, but this works. If we run into trouble, there is also something called collision cooldown, which is a special variable that doesn't allow collisions to be detected for another certain amount of time after a collision has been detected. So that's going to be up our sleeve if we get some glitches, but I don't want to use it until basically program starts running into trouble. I think the thing I want to do here, though, I have a feeling that that's the one we want. So it goes there. I'll just check the left wall. And after that, we're going to get the ceiling. And last but not least, we're going to get the paddle sorted. Yeah. That all works. Happiness. So how do things bounce off the ceiling? Okay. Let's have a look. If we had if we just reverse the Z rotation, so I don't know how to describe it to you, but if you've done the unit circle in trigonometry, if you take an angle that's like 70, then the angle minus 70 would be like the ball bouncing back off the ceiling, right? So like if you just sort of take the negative, then that should work. Ball dot rotation underscore z equals to negative ball dot underscore z. And just take my word on it. I guess let's try minus 50 here, and let's see, let's watch it bounce off of that correctly. Don't. Cool. So we're bouncing off of the ceiling, the wall, and things are looking good. We're staying within the space. So now, finally, the paddle. How are we going to handle this? Well, I guess we're going to need to calculate like how far off the center of the paddle. I'm just going to call it like delta. And delta is going to be hit info.entity. So like, given that we're doing ball intersect, it's going to be hit info.entity, right? That is going to be the x of the paddle. I really could have just written bloody paddle.x. I mean, that might make more sense. It's the paddle x and the paddle x minus ball.x. So if you hit in the center, that delta is going to be 0. If you hit to the right, then that's going to be some decimal. And what you want to do is use this delta to point where the ball is going to go. So if you basically say, right, ball dot rotation z equals to delta times x plus. So imagine you want to point the ball up, because if that's 0, you want like pointing up, which is like minus 90, I think, or 270 or minus 90, whatever you want to do. So like if this was delta times, let's just make it times 10. I don't, minus 90. So I don't know if there's going to be any difference between minus 90 and plus 270, but like just watch here. It should deflect. When we hit it, right, I'm going to try to hit it with the center of the bat. And when the center of the bat, it should deflect like straight up. Watch. Huh? Well, that was ridiculous. But I did the ball rotation there and everything. It should have changed direction. If you hit info, is the paddle. That's delta. Ball rotation. Yeah. See, I don't even know how this was allowed. I misspelled rotation. Rotation. Jeez. That must have been it. So, like, the fact that that didn't bring up an error is just alarming. So, yes, see how it bounces straight up? So now we're going to try the edge to figure out, like, whether it was 10 times was the right amount. Ooh, I think it's not only, like, it's going in the wrong direction. Watch this. It'll bounce slightly to the left here. Yeah. So, instead of minus 90, I mean, I don't know, plus 270, it doesn't make sense because it should be the same. Maybe like we need to reverse that. 270 like 270 minus that. All right, let's try 20. Just check that it's going in the right direction. And if it is going in the right direction, then, you know, rock and roll, baby. Ha! It is going in the right direction, but like 20 is nowhere near enough. I mean, how much do you want to be able to bend it? 60? 80? Like, watch. Yeah, more. I don't care. 80. So, once we get this guy to be able to aim the ball, basically, and now you can aim the ball really should be a lot faster, but we'll worry about that later. This is all perfect for testing. Once you can get once you have all of the elements that we do, I think that we can create some bricks. So, how do we do that? Well, I guess you know, we're gonna need like a double loop for x in range something, and then for y in range something, and then we're going to create like a brick. Ooh, we definitely want to have like a list of bricks, so maybe bricks is a list, and brick equals to entity, and you just sort of want to draw like a quad, and you want to draw a quad on some type of a range. So we're gonna need like, I don't know, I mean, how does the, like, if the screen begins at -4 on the x, so watch this, like -4 to 4, and that's gonna be the range, and then this is gonna be -3 to 3. So don't worry, these numbers, like, we're not really trying to get it right. We're just trying to prove the concept here. So if this was something like a ceiling, right? I'm just going to just hang here, right? We're gonna turn the bricks red. We are going to have them on some sort of scale, and let's see, like, if the paddle was 1.5, right? So brick is going to be scale 1, 0.2 or maybe make it 0.3, and this is the position, right? What if this was x comma y, right? Okay, see, we got some bricks here. They're too wide though. They're too wide. Like, one is like 0.3. Just to see, just to show you how scattered they are, this should work. See, there you go. Those are the bricks. So now we just gotta figure out how to, like, how to make that work. So if for x and y, I mean, like, let's just say I'll just do you guys a favor and I'll copy out this code, because this took, I kid you not, about 20 minutes of finagling trying to get the numbers right. And how is it that my other game has a completely different scale? Maybe because I have an editor camera that changed the proportions or something. Great. So that editor camera changed the proportions, and so my proportions were all wrong compared to that. Jeez. All right. What do I gotta change now? Let's just start with the ceiling. Okay, so this was like 16, because everything seems to be double the width. And what positions are you going to be in? Let me just try. I just made things wider. Okay, so we need more height on the ceiling. 3, 4? Is this 4 enough? Yeah. And then these guys could be like double, I guess, 7.2. That's, I guess, a lesson we should learn. Oh my god, this seems to be working. I need to change the position of the paddle. I probably need to make the paddle a bit bigger. So paddle can be 2 here, and I can make it, what if it was -4? Would it still fit in if it was like flush with the bottom? Yeah, I don't know. Like, this is fine. This was actually surprisingly quick. Let's see how good the collisions are. Make that ball ever so slightly bigger. Ball 0.5. I guess that's not ever so slightly. Let's see how much bigger that is. That's too big. I did mean slightly. Yeah, that'll do. Okay, so we've got the bricks, we've got everything on the correct dimensions, and now we are going to figure out how to intersect with bricks. Let's do that. So we've got ceiling, bowl, and finally if hit info.entity. Now, if this entity in bricks, then we've hit a brick. What do you do if you hit a brick? Well, you're gonna need to bounce the same way you would off the ceiling, wouldn't you? So you're gonna redo the Z rotation, right? Except, of course, you want to destroy the brick, and you want to start somewhere on the screen and not on the bricks. So where is the ball created? Position, maybe begin with a slightly negative Y, and maybe face downwards, which was, I think, I don't know, was it 90? Yeah. And it bounces. So now we destroy the bricks. There is a thing called like the dot destroy. Destroy. Let's see that. So let's see if it's going to get rid of a brick. No attribute destroy. Oh, sorry. The function went like this. Destroy that. And if that works, then we can also remove it from the list of bricks. And destroy. Let's see. Boom. There you go. That works. So we don't really have like winning, losing conditions yet. And this ball sure could be a bit faster. In fact, why don't we like ever so slightly increase the ball speed every time we hit it? So if you hit the paddle, ball.speed times equals to 1 point times equals, actually better, this is nicer, times 1.01. So it gets 1% faster. So it'll start off slow, but it'll just keep getting maybe 2% or whatever. But we can just keep slightly increasing the speed. I thought that that might destroy 2 bricks because it's going to be like colliding with 2 of them at once. The collisions remain accurate enough. Yeah, that's all pretty good. So we really have, in under an hour, reached basic proof of concept breakout, right? So at this point, you can create some global variables for score and have some text displays that are going to make the game work. Perhaps create some more custom-made functions. These functions could serve to maybe display the score on the screen or end the game or something like that. But yeah, this thing works. Sorry, I was gonna say bricks dot remove. Think that can go there. So let's see if I can, I just want to make sure this doesn't cause an error. And if this works, we're going to wrap it up in the next 10. Okay, so that hasn't crashed. Brilliant. All right. So now we can create some sort of a global variable. We can call that score is 0. Every time we destroy a brick, score plus equals to 1. So now, like, you could also declare, I suppose, like, if all the bricks are on the screen, and I think all the bricks are on the screen, you could say if len breaks double equals to 0, we could win, right? It's sort of, I don't want to spend half an hour playing this, but yeah, okay, so that could be the winning condition. And print win for now. And when do you lose? Let's do the losing condition. So the losing condition is if ball.y, so if you like miss it, and ball.y falls below the screen, so maybe less than -5, print you lose. I suppose it's worth testing the losing condition. I'll just get out of the way, and it reference before assignment. How about now? So if I get out of the way, it should start printing you lose aggressively. Is it still running? Let me think of that for a second. Yeah, no. It's not inside info.hit. That should be there. And it should just start printing you lose like crazy here. Yep, that works. So it's all right. Stop that. And so now that we've just sort of proved how these work, I would like to write a function for ending the game. And that function is going to contain a message, and it will also sort of like freeze the screen with that particular message. Okay, so this is going to be the last function. So I'm going to call this def end game. Alright, so that's going to be the endgame function. The endgame function is going to have a user message, a message for the user. So obviously that's going to be a string, and we're going to use a message. That's going to be like a message object. So that's the text object, and in there you decide what your text is going to be, and our text is going to be whatever we say here. Then we specify scale, and from experience I figured that 2 is the right one. Origin, I don't know if this is like a required parameter. I believe 0, 0 would be the default, but that's what it is, so we might as well specify it. Background present, and color. Color equals the color dot green. Alright, so if we get green color, that would work. So let's try the endgame function. End game. Here's the message. You lose. Maybe specify score plus. Let's see if that works. Oh, one more thing. Application.pause. Application.pause. So this will sort of freeze the application, because last time you guys didn't notice, because I sneakily had to restart Visual Studio Code when it was saying you lose on a loop. Ooh, look at that. You lose score 1. And this could be I guess you don't need anything. You could just, you win. So how in the world, are we going to test that this is going to work? Can I count how many bricks we got? 1, 2, 3, 4, 5. 5 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 70. We have 70 bricks. So why don't we just like, I don't know, less than 60. So that's going to be set to 0. I just want to make sure that this thing works. So when I destroy 10 bricks, it's actually going to tell me that I win. If that is the case, then the game is indeed complete. Line 47. You need to remove hit info dot. You're removing that entity. Let's try that again. So, brick 1, brick 2. Why not, for the fun of it, make it 10% more? This is going to be pretty radical in terms of how much faster this is going to get with every hit. It might be fun to play, but it'll be over so quick. Here we go. Boom. It's already getting faster. We're going to win. Oh my God. 10%. 10% a pop. Did I destroy 10 bricks? Yes, you win. So if it works on 10 bricks, it's going to work on double equals to 0, and when there are no bricks left. And please don't do that. That's going to make the game impossible. Maybe 1.02, so 2% faster with every hit. I think that's how the original Breakout worked. So you pretty much got to get your sort of ball in behind the bricks as soon as possible. And there it is. 60 lines under 1 hour Breakout game in Ursina Python. So I hope you guys enjoyed that as much as I did. Catch you later. More videos coming up on the topic of Ursina. Take care and subscribe. Please do. Bye bye.